So, hello everyone. My name is Harsh, and today we will be having the post-contest discussion for the Leetcode Biweekly Contest. So, we would be solving all the four problems A, B, C, and D. So, before we start, I would like to tell you a little about our newly launched version 2 of our favorite CP1 sheet. So, for all those who are not aware, the sheet encapsulates 31 handpicked problems in each rating from 800 to 1900. So, we have updated it to 1900 now, and they are carefully chosen so that every problem teaches a unique idea. So our sheet has now been upgraded with a new interface as well, automatically syncing your progress directly from code forces and a dedicated discussion section for each problem. So there is a leaderboard on the sheet and where you can find yourself and your friends competing on who solves more problems. So added to this, every week 7 to 8 video solutions will be released. So no more wasting time searching for the right problems. And the link to the sheet is in the description. Check it out and start solving. So saying that, let's move on the first problem of the PCB now. Okay. So this is the first problem. You can just check the sheet for that. So this was the first problem for the day. The name of the problem was transform array by parity. So you are given an integer array nums. Transform nums by performing the following operation in the exact order specified. You have to replace every even number with 0 and every odd number with 1, and you need to sort the modified array, the array which you get after doing this, replacing every even number with 0 and every odd number with 1. You need to sort this modified array in non-decreasing order, basically in ascending order, and you need to return the result after performing these operations. So as you can see with this particular example, the array is 4 3 2 1, 4 3 2 1, and as told, you have to replace every even number with 0 and every odd number with 1, and after this you want to sort this array. So after sorting you will get this particular array and you need to return this particular array. So this is what the problem statement is. Anyone having doubt in the problem statement? Anyone having doubt in the problem statement? No. Okay. So the solution to this is pretty straightforward. So what we can do is we can just go through this array. Every time when we find an even number, replace that with 0. Every time when we encounter an odd number, replace it with 1. After that, whatever array you get, just call a sort function to that array and you will get the sorted array. So this is how you can obtain the solution to this problem. Do you guys have doubt in this? Any doubt, guys? So let's go through the code as well. So what I have done is I have just constructed an answer, went over this vector nums. If the number is an odd number, so this is how we can check whether the number is odd or not. There are two ways. Either you can check by this, or you can even check like this, IT modulo 2 equals 1. So there are two ways you can check whether the number is odd or even. So if it is an odd number, then to our answer, we are pushing back 1. Otherwise, to our answer, we are pushing back 0. So at the end, whatever answer, which is actually the modified form of nums, is obtained, we simply sort that answer vector and return that answer. So this is how you can actually solve this problem. Any doubt, guys? No? Okay. So let's move on to the second problem. So the name of the problem is find the number of copy arrays. Okay. So you are given an array original of length n and a 2D array bounds of length n multiplied by 2, where bounds of I is ui vi. Okay. So you need to find the number of possible arrays copy of length n such that copy of I minus copy of I minus 1 is equal to original of I minus original of I minus 1 for every I from index 1 to n minus 1. And every value in this vector copy that you are forming should be greater than equals to ui and should be lesser than equals to vi. where ui comma vi is actually denoted by bounds of I. So you need to return the total number of such arrays. So let us first of all try to understand this problem via this particular example. So in this particular example, the original array given is 1, 2, 3, 4. So original array given is 1, 2, 3, 4, and bounds given is, if you just observe, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So the first number should lie between 1 and 2, both 1 and 2 included. The second number should be greater than equals to 2, less than equals to 3. Third number should be greater than equals to 3, less than equals to 4. And fourth number should be less than equals to, greater than equals to 4 and lesser than equals to 5. So this is what bounds array denotes. So what you need to do is you need to construct a copy array. Okay, you're constructing a copy array and it will again be the size of that original array only. So it will be of size 4. So basically it is going to contain 4 elements. Okay. So element 1, 2, 3, 4. And what you want is for every index I greater than equals to 1 and lesser than equals to n minus 1, copy of I minus copy of I minus 1 should be equal to original of I minus original of I minus 1, right? This is what you want. Now just tell me one thing. So let's try to see how we can actually fill it. Let's try by filling the first number as 1. So if I fill the first number as 1, so second number should be 2, third number should be 3, and fourth number should be 4. If I do this, then you can clearly see that for any index I from 1 to n minus 1, copy of I minus copy of I minus 1. So 2 minus 1 over here also 2 minus 1. 3 minus 2 over here also 3 minus 2. 4 minus 3 over here also 4 minus 3. So all the differences are equal. Like copy of I minus copy of I minus 1 is equal to original of I minus original of I minus 1 for each and every index I from 1 to n minus 1. So this is one of the possible copy arrays. Similarly, if you see, I can say this is also one of the possible copy arrays. 2, 3, 4, 5. Why? Because if you just see the difference of adjacent elements in original array, it was 1, 1, 1. Over here as well, the difference is 1, 1, 1. And for every index I, copy of I is greater than equals to ui and lesser than equals to vi. So this is also one of the possible copy array that you can form. Now in the question, what they have told is they don't want you to construct this copy array. They only want you to tell how many copy arrays you can actually construct. So tell me, is the problem statement clear? So for this particular example, our answer will be 2. You can actually construct in total 2 copy arrays. Question clear, guys? Anyone having doubt in the problem? Problem statement clear? Yes? Okay. So how we can actually solve this? Now, when I was thinking of this problem, so if initially you observe this seems to be a pretty tough problem. Like you will think that how we can actually fill it. Like one number we fill, we also need to take into consideration that a number should be greater than equals to ui and lesser than equals to vi. And again, this condition should also be maintained. So if you think like this, then it seems that the question is very tough. But if you try to form just one of the copy arrays, you will get a very beautiful observation. Let me say you how. For this particular example only, let me start the first element with 2. Okay, let I start the first element with 2. I can definitely start with 2 because 2 lies between this range 1, 2, right? So first element can be started with 2. Now on the basis of what I have kept as my first element, do you guys agree that the second element is fixed? What is second element? Second element is original of 1 minus original of 0 plus copy of 0. Do you guys agree that this will be my second element? My second element is fixed. Do every one of you agree? that if I want to maintain this particular condition, that copy of I minus copy of I minus 1 is equal to original of I minus original of I minus 1, then if I fix the first element, then second element is also fixed. Anyone having doubt in this, guys? Similarly, can I say that the third element will also be fixed? Because if this is fixed, then this will be fixed. Agree? And very similarly, can I say that fourth element will also be fixed? Do you guys agree? If I have fixed the first element as 2, the second element should be 3, the third element should be 4, the fourth element should be 5. So if you guys just observe, there is a very beautiful thing happening over here. If let's suppose I say that in the original array, my elements are A1, A2, A3 up till AN. So I'm just taking an example of 4 with 4 elements. So A1, A2, A3, A4, and the differences are actually, let's suppose A2 minus A1 is Y1, A3 minus A2 is Y2, and A4 minus A3 is Y4. Then do all of you agree? Just tell me, do you guys agree or not? That if I say that the first element is X, then the second element will be X plus Y1, third element will be X plus Y1 plus Y2, and fourth element will be X plus Y1 plus Y2 plus, let me name this as Y3. Then just say me, do you guys agree that the fourth element will be X plus Y1 plus Y2 plus Y3? Do you guys agree with me in this copy array, whatever I have written? Do all of you agree, guys? Anyone having doubt in this? No. Okay. So basically, if I am fixing the first element, so the second element is getting incremented by y1, third element is getting incremented by y1 plus y2, and fourth element is getting incremented by y1 plus y2 plus y3. So just tell me, and the first element is getting incremented by 0, saying that the number that I have fixed is x. So x will get added by, so we will add x to all of these and I will get an array. So just tell me one thing. Can you compute this particular array? Do anyone have any doubt how you can compute this particular array? 0, y, y1 plus y1, y1 plus y2, y1 plus y2 plus y3. We can do this, right? Once we construct this array, difference array, by taking the adjacent element difference, we can just take the prefix sum after that and we will get this particular array, right? Do all of you agree that constructing this array is not tough for me? Right? Okay. Now comes the interesting part. The first element lies from U0 to V0, right? So can I say that the minimum element, the minimum value of this X that I can choose is actually U0, and the maximum value of X that I can choose is actually V0. Can I say this, guys? That the minimum value of X that I can choose is U0, and the maximum value of X that I can choose is V0. After choosing X, do you guys agree that this is the minimum value and this is the maximum value that I can choose? Now just tell me one thing. If I say you that for the second element, okay, let's just observe for second element and the things will become very clear. For the second element, let's suppose I tell you that the value of this difference, that is this y1, was let's suppose 4, u1 was let's suppose 6, and u and v1 was let's suppose 9. That is, the copy element should lie from 6 to 9 and the difference was 4. So you know that this 4 plus x, whatever you are choosing, should be greater than equals to 6 and should be lesser than equals to 9. Do you guys agree? Do you guys agree that this 4 plus x, whatever first element I have chosen, 4 plus x, this is going to be the second element, right? Do you guys agree that this is going to be the second element if the first element is x? Yes. So can I say that this being the second element, and since the second element has an additional constraint that it should be greater than equals to 6 and lesser than equals to 9, can I write this thing? From here, can I write that x should be greater than equals to 2 and lesser than equals to 7, guys? Can I write this? Can I write this? Yes, I think now you can solve this problem. So let's suppose the first problem had u0, the first one had the bound u0 equals to 4, let's suppose u0 equals to 4 and v0 equals to 9. Let's suppose we had this. So this means that x is greater than equals to 4 and lesser than equals to 9. Right? This means that x is greater than equals to 4 and lesser than equals to 9. And the second element requires that x is greater than equals to 2 and lesser than equals to 7. So combining these two results, can I say that x should be greater than equals to 4 and lesser than equals to 7? Can I say this? So can I say the total number of possible values of x is actually 4? That is 4, 5, 6, and 7. And once you are fixing the x, the copy array gets fixed. So the total number of possible copy arrays that you have is 4. So similarly, do this for each and every element. Take the merge of all of them to get this thing, that x should be greater than equals to what and lesser than equals to what. Once you get these things, now you can easily, like let's suppose this value comes out to be mini and this value comes out to be maxi. So you can say the number of possible arrays that you have is maxi minus mini plus 1. So basically, to get the intersection of all these x, just take the maximum of all these minimum values. Of all these minimum, take the maximum, and of all the maximum, take the minimum. Like let's suppose if I tell you that x should be greater than equals to 2 and lesser than equals to 9. This is the first element requirement. For the second element tells me that x should be greater than equals to 4, lesser than equals to 7. Third one tells me x should be greater than equals to 5 and lesser than equals to 11. Fourth one tells me x should be greater than equals to 1 and lesser than equals to 6. So can I say by combining these all, my x should be greater than equals to maximum of all these values, that is 5, and lesser than equals to minimum of all these values, that is 6. So this is going to be my final intersection, and I would be able to say that the total number of possible arrays I have, possible copy arrays that I would have is 2. Is it clear, guys, how I am going to solve this problem? Was it tough? It was not tough. If you would have tried to construct one copy array by your own, you would have observed that once I fixed the first element, the entire array gets fixed. And since every element has the condition, so now you can go to each and every element, take the intersection of all the conditions, and you will get the answer. Okay, no problem. Is it clear now? Yes? Okay. So let's try to see the code for this as well. Just a minute. Okay. So this is the code. So first of all, I am trying to construct this particular array. Okay. The 0, y1, y1 plus y2. This is what I am going to construct. For that, first of all, I will construct this thing. So let me do one thing. Let me just modify a code a bit so that because in the contest I have written, just give me a minute. Dot push back 0 and I lesser than m. Just give me a minute, like exponent I equals to 1. So let's see the code now. So wrong answer on second question. I don't remember. I have to see that. I will show you at the end. Okay. So I have this vector C. So initially I have the size of this original vector n. So inside my C, first of all, I am pushing back 0. So as you guys can observe, the first element is 0, right? And from the second element, for every element from index 1 to lesser than n I plus plus, I am just in my C pushing back original of I minus original of I minus 1. So I have this thing now. I have this thing as my C. So from this thing, if I want to reach this thing, what I need to do? I need to do a prefix sum, right? So I'm just doing a prefix sum for int I equals to 1, I lesser than n I plus plus, C of I plus equals C of I minus 1. Okay. Then I initialize my maximum to the upper limit of first element and minimum to the lower limit of first element. So bounds of 0 of 1 and bounds of 0 of 0. And now for every corresponding element from index 1 to lesser than n I plus plus, the lower limit is this, the upper limit is this. So I know that to this, like whatever I can keep. So what will be the element at this particular index I? The element will be x plus whatever you have C of I. So this x plus C of I should be greater than equals to the upper limit, sorry, the lower limit, bounds of I of 0, and it should be lesser than equals to the upper limit, bounds of I of 1. So from here, what I can say that x should be greater than equals to this minus C of I and should be lesser than equals to this minus C of I. So what I am doing, I'm just updating by minimum variable to maximum of mini comma x minus C of I and maximum variable to minimum of maxi comma y minus C of I. So basically I am taking minimum of all the maxi and maximum of all the mini, as I have explained over here. If you guys observe this, as this is what I have explained. For all the maxi, take the minimum, and for all the mini, take the maximum. So this is what I am doing. At the end, if my maxi is, let's suppose, lesser than mini. So this is not possible, right? This means you are telling that the upper limit of x is lesser than the lower limit of x. So that does not make any sense. This means you can't construct even a single copy array. So simply return 0. Otherwise, if the lower limit is mini and the upper limit is maxi, so the total number of possible values of x and basically the total number of copy arrays that you can construct is maxi minus mini plus 1. Is it clear, guys? Do you guys have doubt in this? Should I move on to the next problem? Yes? Okay. So for the second problem, I can just confirm. Did I get a wrong summation? No, I didn't get a wrong summation for the second problem. For the third one, I got 2 wrong summations. Okay. So this is the third problem. Okay. So I have done this problem via DP. I don't know if there exists any other approach. I didn't got time to look for that. If anyone does not know DP, not a problem. What I will try to do is I will try to understand the recursive approach of this. Even if you understand the recursive approach, it's good to go because I have simply memoized that. So the DP is just one step forward. So no, I don't go by that subtopic, so will be hard to say, but like it was a normal DP. I simply wrote a recursive code and memoized it. So you can just look. Just understand the logic and try to, if you don't know DP, try to understand the recursive approach. Okay. Cool. So let's first of all try to understand the problem. The problem name is find minimum cost to remove array elements. So you are given an integer array nums. Your task is to remove all elements from the array by performing one of the following operations at each step until the array nums becomes empty. What you can do, you can choose any 2 elements from the first 3 elements of nums and remove them. The cost of this operation is the maximum of the 2 elements removed. If fewer than 3 elements remain in nums, remove all the remaining elements in a single operation. The cost of this operation is the maximum of the remaining elements. So what you need to do, you need to return the minimum cost required to remove all the elements. Okay. Let's try to understand this problem via this particular test case 6284. Okay. So the array given is 6284. What they have told in the problem is you can choose the starting 3 elements, whichever 3 elements are not removed, the starting 3 elements, and from them you can choose any 2 elements and remove them. Any 2 elements I can choose and remove them. Let's suppose I choose these elements 6 and 2. So I can remove both of these elements, and once I remove them, what gets added to my score is the maximum of the elements I am removing. So over here, since I am removing 6 and 2, so the score that will get added is 6. Okay. Now, once I remove these two elements, the array changes to 8, 4. And since this array has lesser than 3 elements, so you can remove all the elements from here, and the score that will get added is the maximum of the elements you are removing. So the score that will get added is 8, and both of these elements will get removed. So once I do that, the score that I get is 14. Now the problem is you need to minimize this score. The problem says that tell what is the minimum score that you will get. So basically, if you just see another possible scenario, let's suppose I have this array as this 6, 2, 8, 4, and I chose that, okay, from the first 3 elements, I'm going to remove these 2 elements. So if I remove these 2 elements, the score will get incremented by 8, and now I will be left with this particular array. And again, since it contains lesser than 3 elements, I can remove all the elements, and the score that will get added is 4, the maximum of all the elements I'm removing. So in this case, I get the score as 12, which is definitely a better score as compared to the one I got before, since I want to minimize the score. So for this particular test case, the answer will be 12. So do you guys get the problem, that what the problem statement says? Or do you guys want me to take one more example? Is the problem statement clear, guys? Clear? Okay. So how we can solve this problem? So when I saw this problem for the first time, what came to my mind was that, see, let's suppose I have these elements, okay? Let's suppose I have 5 elements. So first of all, I was thinking that, okay, how many times will we actually remove, or how many times we will actually increment our score over here? Like, see, when I am having these 3 elements, I will be able to remove 2. Let's suppose I remove first 2 only, and my score will get incremented once, the maximum of these A1 and A2. Then again, I have these 3 elements. The score will get incremented by, I will remove 2 elements. Let's suppose these 2, my score will get incremented by 1. And then since I will be left out with only 1 element, again, my score will get incremented by 1. So over here, I would have to perform 3 operations. Okay, this was something that I saw. Then what if instead of 5 elements, let's suppose I have 6 elements. In that case, because basically we were choosing the 3 elements case, so I tried to observe all the modulo 3 cases. So let's suppose now I have, instead of 5, I have 6 elements. Okay, A4, A5, A6. In this case, I observed that how many times I will just simply increment my score. So I am just discussing the way I have actually solved this. Okay, let's suppose we remove first 2 one time, then first 2 again one time, then again lesser than 2 elements we have. So we will have to increment the score again one time. So again over here 3 as well. And let's try to explore this case as well when we have only 4 elements. In this case, if you observe, these 2 will be removed. So I need to increment one time. And then this 2 will be removed. I have to increment one time. So 2 times I have to perform the operation. Okay. So when I was thinking like this, so what came to my mind was that, let's suppose I have this array A1, A2, A3, A4, A5, A6. Let's suppose I have this array. Okay. Now, just tell me, can I play with 2 elements at a time? Let's suppose I have some more elements towards the right, and currently I have 2 elements. Can I perform any operation, guys? Perform any operation if, let's suppose, because what is the operation? You need to have 3 elements, or if you are not having 3 elements, then you should not have more element towards the right. This is the thing, right? So if you have more elements towards the right, then to perform the operation, you should clearly, or you should definitely have at least 3 or exactly 3 numbers to play with. Because out of those 3 only, you will choose any 2 and perform the operation, right? Do you guys agree? Do every one of you agree, guys, that if I have some elements towards the right, and currently I have a bucket with 2 elements, so I can't perform any operation? Definitely, yes. Okay. So every time if I have some elements towards the right, I should have at least 3 elements. So this was the first observation I made. So if I have some elements towards right, then I should contain exactly 3 elements in my bucket to perform the operation. This thing is clear. Anyone having doubt in this, guys? Anyone having doubt in this? Yes, no, no. Okay. Now let's suppose I have 3 elements. And let's suppose those elements are 4. I'm just writing in shorted order. 4, 6, and 9. Let's suppose these 3 elements I have. Which 2 element will you try to remove? Or if I just ask in another way, how many possible options greedily you will decide to remove the numbers? If you guys agree, there are 2 possible options. Either I remove this pair or I remove this pair. I don't have any other possible option, guys. I will never remove 9 and 4. Because if I am doing this, I am doing a blunder. Do you guys agree? I will never remove 4 and 9. Because if I am removing 9, then definitely I am adding 9 to my score. So why should not I remove the second largest element so that it does not get added afterwards at any point of time? So if I am removing 9, so definitely I will go and remove 6 as well. The largest number that I can remove with 9. But if I am not removing with 9, I am not removing 9 and I am removing 6, then I have only one option. I can remove 4 with 6. So these are the only 2 options I have, that I either remove 4 and 6 or I remove 6 and 9. Do every one of you agree with me? Anyone having doubt in this? That I have only 2 possible options and I have exactly 2 possible options. So the second option was, every time when I have 3 elements, I have 2 possible options. And now, if you guys have solved problem of recursion or DP, you guys know every time when we have 2 possible options, why not try for each option once and try to get the most optimal result? Do you guys agree? That if we have 2 possible options, what we will try? Try to explore both possible options and get the answer. The question is not solved, guys. You have to think of how to get these 3 elements as well. Okay. So let's suppose, so these 2 observations are clear, right? That if I should have exactly 3 elements to play with, and every time when I have 3 elements, I have 2 possible options. This thing is clear. Anyone having doubt in this, guys? No, we don't have option of 0, 2. We don't have option of 0, 2. Why? I think you joined late, Himanshu. If you are removing 9, along with 9, you will never try to remove 4, no? Because with 9, you will always try to remove the second largest element. Because anyways, you are going to add 9 to your score. So why not greedily remove the second largest element instead of third largest? Do you get it? If in this, you are removing 9, out of these 3 elements, 4, 6, and 9, you are removing 9. Why greedy won't work? If you have 3 elements, 4, 6, and 9. If you have 3 elements, 4, 6, and 9, and if you are removing 9, then you should definitely remove this 6 as well along with it. Nikunj, are you telling that in second test case, greedy would not work? This thing would not work? Why? I have solved this question via this. Why it will not work? Let's take this 2133. I am telling if I am removing 9. If I am not removing 9, then I will remove this 6 and 4. 2133. Okay. So in this, for the first 3 elements, if I sort them, I will get 1, 2, and 3. So I have 2 possible options. Either I remove 2 and 3 or I remove 1 and 2. You guys can decide. Let's suppose, yes. So let's suppose now we try to remove this 2 and 1 first. So my score will get added by 2. And now my array will be left out with 3, 3. And now I can remove both of these and I will add the maximum of those. So the score will be 5. Is the 5 answer to this problem? Yes, 5 is the answer, right? So it is working now. Where it is not working? What I am telling is instead of 3 possible options, you have 2 possible options. If this array is 4, 6, 9, Himanshu, what I am telling is, if let's suppose you are removing 9. So along with 9, what you would prefer to remove? 10. If you have an array of containing 3 elements as 4, 6, 9, so along with 9, what you will prefer to remove? Because if you are removing 9, 9 will get added to your score, right? So you will remove 6, definitely. Why do you think so much? Because you don't want the 6 to get added anytime in the future. Yes, definitely. So if I am removing 9, I will remove 6 with it. But if I am removing 6 and I am not removing 9, then I will have to remove 4. So you have only 2 possible options instead of 3. So greedily we minimized one option. This is what we have done. Okay. Is this thing clear, guys? Yes. Okay. Cool. So now what I have told is every time if you want to perform an operation, you want exactly 3 elements with you. Okay. So now just tell me one thing. If you come to an element, and this is the first time you are coming to this element, like you don't have any element before, we will see that how we can check whether we have any element before or not. And let's suppose we have one element before, like every time we will have at least one element before. Okay. Let's suppose you have one element before and you came to some element. Okay. So can you guys tell me when you came to this index, how many elements you were having in your bucket? Can you guys tell me? When you came to this element and previously you had one element, so after taking this element, you have exactly 2 elements in your bucket and you can't perform an operation, right? So what I will do, I will move on to the next index. Do you guys agree? That I will move on to the next index. Yes. And next index will give me an element. And after this, I will be having 3 numbers. Do all of you agree, guys? That after this, I would be having 3 numbers. Yes. So the point that I want to make is every time when you arrive to a situation when you have 3 numbers, so out of those 3 numbers, 2 numbers are actually the consecutive numbers of the array. And for the other number, you need to maintain which number is this. This is something that we can maintain given the constraints. But out of these 3 numbers, 2 numbers are the consecutive numbers and those are present at index IDX. Let's suppose you are at current index IDX. So they are present at index IDX and IDX -1. So do you guys get this? That if you are coming to an index and in your bucket you have 3 elements including that number. So out of those 3 numbers, 2 numbers are actually the consecutive numbers. And for the third one, yes, I can take. See, let's suppose I take this particular example, 6284. Let's suppose I take some other example. 2, 3, 4, 9, 3, 6. Okay. Let's suppose out of these first 3 elements, I remove these 2 elements. Okay, I remove these 2 elements. Now when I come to this particular index, how many elements do I have in my bucket? How many elements do I have in my bucket? 2, right? So I will not perform an operation. Now when I come to this particular index, how many elements I have in my bucket? 3. So whenever I am having 3 elements in my bucket, out of those 3, 2 are actually consecutive numbers and the other one lies at some index. This is what I am telling. 2 numbers are actually consecutive and the other one lies at some other index. That is something that we will maintain. Do you guys get this? That whenever I am having 3 elements, so every time the 2 elements, you didn't get it. What you didn't get it in this? See, for the first 3 elements, let's suppose I remove these 2 elements. So the array that I have now is 2936, right? And I am currently at this index. So standing at this index, we have only 2 elements. We can't perform an operation. So I need to move on to the next element, index. Once I move on to the next index, I have 3 elements in my bucket. And out of those 3, these 2 are present consecutively in the array. And the other one is present at some random index. This is what I'm telling. Every time when we have 3 elements, then 2 of them will be consecutive numbers, that is at index idx and idx minus 1. These 2 elements will definitely be present in my bucket, and a third element will be present at some random index before. That is something that we will maintain. Do you get this now? So I got this, that okay, I have to maintain only this element. So from here, I got the logic that I want to have 2 things: the current index that I have, and the other thing is that where the previous number was present. Like out of these 3, whether this third number was present, for this I need to maintain the index. So these are the 2 things that definitely I need to maintain. Do you guys agree? These are the 2 things I definitely need to maintain. Do you guys agree? Yes, no? Yes? Now, along with this, do you guys agree I also need to maintain that when I am coming to an index, then whether I have 2 element with me or 3 element with me, I need to maintain this, right? Because then only I will perform an operation. If I don't know I have 2 element or 3 element, how will I know that whether I need to perform the operation currently or not? Do you guys agree? So what I did in the contest was I just maintained an extra flag which told me that whether I have 2 element or 3 element, but this gave me TLE. Okay. So n multiplied by n multiplied by 2. This approach gave me TLE. So what I did was, no, what I am telling Anand is, like let's suppose you remove these 2 elements 3 and 4. Now when you come to this 9, so you will have only 2 elements in the bucket, right? So you can't perform an operation over here. You need to go to the next index to perform the operation. Do you understand this? Yes. I don't know why it gave TLE. Like, I don't know. It is working for me. It is not working for me from the last contest as well. So 10 power 3 multiplied by 10 power 3 multiplied by 2 actually gave TLE. I don't know why. Okay. Don't ask me the reason, but it gave TLE. I can show you the code, my TLE code as well. It gave me TLE. So yes. So I needed to modify this. I will show it. I will show it. Okay. Once I show the code, I will show it. So what I observed was, there was a very interesting thing happening again. So this is the last observation, guys. After that, I will show you the code. Just observe. These were the elements, right? So I just marked the index 0, let's suppose 1, 2, 3, 4, 5. If you guys just observe the index at which actually I am going to perform the operation. Do you guys agree that I am going to perform an operation at index 2? Do you guys agree that I am going to next perform an operation at index 4? And then at the last index, I will definitely perform an operation. So the logic was, starting from index 2, I will perform operation at every even index, along with if my index is the last index. So this is where we are actually going to perform the operations. Because every time when we come to these indices, we will have 3 elements in our bucket. And for the last index, we can have either 2 or 3 elements in our bucket. It varies. So for that also there is a logic. If you guys just observe, if the value of n is even, like it is 6, since the value of n is 6. So can you guys tell me at the end how many elements will I have in my bucket? I will remove these two. Then I will remove these two. So in case of 6, I will have 2 elements in my bucket at the end, right? In case of 6, I have 2 elements in my bucket at the end. Similarly, in the case of 7, or let's suppose in the case of 5, how many elements do I have? Let's suppose I remove these two. Then out of these 3, I let's suppose remove what do you mean by that? Do we to remove? Matlab? Where? I remove these 2 elements first. Yeah, we will have 2 elements now. We will have 2 elements at the end remaining. Is there any confusion in this? Is there any confusion in this, guys? The 2 elements? No. Okay. Okay. Similarly, if let's suppose we have 5 elements, so in this case, at the end, how many elements will be left out? 1 element will be left out, right? Like if you have 3 elements at the end, and this third is one is actually the at the last index. So basically, you have to perform operations twice over here. First of all, you have to choose 2 elements, remove the maximum of all, and then 1 element will be remaining. So we will check that. Okay, we will check that in our base case, that when we are coming at the last index, then how many elements actually is remaining. So this is actually the proper thing of how actually we can solve this problem. So the observations that we made was, yes, it was actually a good problem. So if you just look up to the observations that we made, the first thing that we concluded that, okay, if we are performing the operation, either it should be the last index or we should have 3 elements in our bucket at least. Okay. Then we saw that if we have 3 elements, then there are two possibilities or 2 types of operations that we can perform, either with the largest 2 elements or the smallest 2 elements. These are only the 2 possibilities that I have. So saying that, now I observed that at which index I will actually perform the operation. So for every index starting from index 2, I will perform the operation at even indices and at the last index. So this is the observation that we made, and after that I will just show you the code. Anand, again, as I told, I didn't thought of any other thing since I just gave the contest, had my dinner and came here. So have to think for any other solution if it exists. But for now, this is something that came to my mind. And looking up to the constraints as well, since the n was given of the order of 10 power 3, so I thought that this would definitely work. So this is something that came to my mind. So should I show you all the code now? Yes, okay. Uh, okay, I have written a lambda function for this. Just give me a minute. I will just quickly change it to a non-lambda function. Int helper. Uh, Let me change it, Himanshu. Otherwise, like many people don't understand the lambda code, so it's better we change it. Just give me a minute. It will not take much time. And you. Okay, we have IDX, previous nums, and DP. I just need to change the things over here. Okay, and where? Hmm. Mhm. Okay, think it will be good to go. Let me just run this. Okay. So let's discuss this code. Okay. So just yes. So just tell me one thing. If the size of the vector given to you is lesser than equals to 2, in that case we have lesser than 3 elements, right? So we can just remove the maximum of 2 elements. We can just return the maximum of whatever the element that we have to our answer, right? Do you guys agree that if I have lesser than equals to 2 element and I can return the maximum element of this nums? Do all of you agree, guys? Do all of you agree? Yes, no? This thing? Yes? So this is how I just wrote a code for returning the maximum element. So there is a syntax in C++ star maximum element nums dot begin nums dot end. It will give me the maximum element in this vector nums, and I am simply returning that. Okay. Anyone having doubt in this? Why so less people are writing yes? Do you guys get this? Yes. Okay. Otherwise, what I have done is I have constructed a DP, and for the first index will be actually IDX for the DP, and the second one will tell me actually the previous index that I have chosen. Okay. So for that, I simply constructed a 2D DP, and I am simply returning this. So initially, the first index that I am at is 0, and this is only the previous element that I have chosen, right? Do you guys agree that this is the first element and this is only the previous element that I have chosen, right? So I'm just passing these two things, and nums and dp are just passed by ampersand by reference. Now let's see this particular code. So first of all, in my variable n, I took the size of this vector nums. If my idx is greater than equals to n, if my idx is greater than equals to n, then what I am doing, I am simply returning 0. Because if I have exceeded the index, then nothing will get added to my score, right? So I am simply returning 0. Do you guys get this? Yes? Okay. Otherwise, I know that I need to perform the operation at every even index from index 2, and I need to perform the operation at the last index as well. So I am handling this case of last index over here if my index is the last index, basically n minus 1. Okay. So if my index is the last index, so I'm handling this case over here. So if my index is the last index and this index is actually an even index, this index is the last index and this index is actually an even index, then do you guys agree I would have 3 elements in my bucket at this particular point of time? Do you guys agree? If this index is the last index and this index is an even one, because we know that for every even index starting from index 2, if I am coming to that index, then after coming to that index, I will have 3 elements in my bucket. We have discussed this, right? Do you guys agree? Anyone having doubt in this? That once we come to any index after 2, or like after in 2 including 2, and that particular index has an even value, then when we come to that index, we will have 3 elements in our bucket. So if I come to the last index and that index is actually an even index, then do you guys agree the 3 elements that I would have in my bucket is the element present at IDX, the element present at IDX minus 1, and the element present at index previous. Do all of you agree, guys? So what I did was I constructed a vector, pushed all of these 3 elements in the vector, shorted the vector, and now just tell me, shouldn't I return v of 0 plus v of 2? Because if I have last 3 elements, then what will I do? I will return the maximum element and the minimum element. Let's suppose I have these elements only 3, 6, and 9. Then what will be my score? I will choose these 2 pairs and add 9 to the score, and then this remaining element will get added. So for the last 3 elements, the answer that I will return is v of 0 plus v of 2. Do you guys agree? Yes. So that is only what I am doing over here. That if the index is an even one, so I know that these are the 3 elements that I have, shorten the vector, and I am returning v of 0 plus v of 2. Anyone having doubt in this, guys? No, right? Okay. Else, if the index is not an even one, then how many elements do I have in my container? Can you guys tell me? 2 elements. And what are those 2 elements? The element present at index IDX and the element present at index previous. So if I have 2 elements, what will I return? I will return the maximum of those elements, right? Do all of you agree? Yes. So now this becomes my base case. Okay. Anyone having doubt in this? How I have handled the operation at the last index? No, right? Okay. Now this is the memoization approach. So let's keep this for now. For the guys understanding the recursive approach, I will come to this. So now if the index is lesser than equals to 1, I know that the array contains minimum 3 elements. Because if it was containing lesser than 3 elements, I have already handled that case. So just tell me one thing. If the index is lesser than equals to 1, then can I say I should simply move on to the next index? Can I say this, guys? Because first of all, let's reach to that index 2. Then we will see anything else. Right? So we can start this index from index 2 as well, keeping the previous element as 0. That would also work. So let's do that only. Let's start this with index 2 and let's remove this case only. Let's remove this, not needed. So yes. So just tell me one thing. If you have some elements in the array, just tell me one thing. These 3 elements are going to be your first 3 elements, right? And for these 3 elements, you will start the operation from index equals to 2 and your previous will be 0. Because you know when your index is 2, so the element that you have is IDX, IDX minus 1 and previous. These are the 3 elements that you have. So to element at index 2, element at index 1, and hence your previous should be 0. So can I say that I can perform the operation? I can start performing the operation from index 2, keeping my previous as 0. Can I say this? So that is what I am doing. I am starting with index 2, keeping my previous as 0. Okay. Because I know I have minimum 3 elements. Because for the lesser than 3 elements, I have already handled that case separately. So now, if my index is an even index, so I know, just tell me how many elements I have in my container at this particular point of time, if my index is an even index. 3, right? So I need to perform an operation. And while performing the operation, I will sort the vector. And once I sort the vector, just tell me one thing. If I am having 3 elements, I know the element at index idx, element at index idx minus 1, and element at some random index previous. When I sort these three elements and when I remove these any two elements from these, so I will be left out with one element, right? Do you guys agree? I will be left out with one element. Agree, guys? And the element with which I am left out with, I should know the index of that element, right? I should know whether that element was at index idx minus 1 or idx or previous, where that element was actually present. I need to know that, right? Do you guys agree? That whichever two elements I am removing, I need to know which element I haven't removed. I need to know the index of that element. So what I am doing is, I constructed a vector pair of int comma int. So this II actually resembles pair of int comma int to maintain the index as well. So now in my vector, I am pushing nums of idx along with its index, nums of idx minus 1 along with its index, nums of previous along with its index. And I simply shorted this vector. Now, as we discussed, we have two options, and I am simply returning the minimum of both of the options. So the first option is I simply move on to the next index where I remove the largest two elements. So if I remove the largest two element, so the first element will be left out, right? And what is the index of the first element? It is actually present at v of 0 dot second. So that element will be left out, and the score and the number that will get added to my score is the largest value. The largest value is nothing but v of 2 dot first. So this is one of the options that I have. Do you guys agree? When I am removing the largest two elements. And when I am removing the smallest two elements, in that case, the largest element will be left out. So the index of that element will be v of 2 dot second. So I'm just moving to the next index. This element will be left out. And the thing that will get added to my score is the value of second largest element. So basically v of 1 dot first. So I'm just returning the minimum of all of these possible options. And let's suppose my index was not an even index. In that case, I currently have two elements in my bucket. So I can't perform an operation. So I simply move on to the next index and keeping the previous as same. Right, Nikunj. Right. So this is how actually we can solve this problem. So what I have done is I have just memoized it using DP. So DP of idx previous not equals to minus 1, and I am returning this value because I already computed this state before. And whenever I am returning the result, I am just storing that in this particular state as well. So this is what I am doing. And I have initialized the DP with minus 1. So if anyone knows DP, memoization approach is the basic requirement or the first thing that we do. So this is a very simple memoization approach. So once you are able to write a code of recursion and you know a bit of DP as well, you can just memorize it. Right. Instead of calling for idx plus 1, can't we do for idx plus 2? See, there will be a problem, Anand. The thing is, when last element, when you reach to index n minus 1, there are cases where you will be left out with only two elements instead of three. So you can't go to idx plus 2 directly. There will be problem in the last element. Are you able to relate? When you are coming to the last index, there are cases when you will be left out with only two elements, right? So you have to perform operation there as well. So what I told, you have to perform operation at every even index starting from 2 as well as at the last index. So if you do idx plus 2 every time over here, so you will miss that last index case. So that is why we are every time doing idx plus 1. So I can just show that I got TLE for that flag. I can just show this submissions. Yes. See, when I wrote the code with flag, as I told you all, the same code, exactly the same code, only I was maintaining a flag for checking whether I have to perform 2 operations or 3 operations. So at that point of time, I got TLE. So that's why I just just optimized it a bit, because coming to an index and seeing the parity of index, we were able to judge where we need to perform 2 operations or 3 operations. Right. Okay. Cool. So let's move on to the last problem for the day. Okay. Previous का code समझा? Oh no, the code was same only. Like, see, since over here I am on the basis of parity of index, I am checking whether whether I have to perform whether I have 2 elements or 3 elements in my container. Over there, I was maintaining a flag for that, a binary flag. So let's not go into that. That is anyways giving TLE. Right, right. There was a check. So I think you joined late. I actually discussed this before only, that I first of all maintained a flag, but seeing the TLE, I just optimized it a bit. Okay, cool. So let's discuss the last problem for the day, that is permutations 4. Just give me a minute. Okay. So the name of the problem is permutations 4. So given two integers n and k, and alternating permutation is a permutation of the first n positive integers, such that no two adjacent elements are both odd or both even. You need to return the kth alternating permutation sorted in lexicographical order, and if there are fewer than k valid alternating permutations, return an empty list. Okay. So do you guys understand lexicographical order? Yes? Okay. So let's see how to solve this problem. Yeah. So in the problem, you are basically given the value of n and k. So let's suppose n is 4 and k is 6. Can I tell my approach? We will just, for this particular problem, permutations. For this particular problem or the last problem? This. Okay. I'm allowing you to unmute. Go ahead.
Hello. So
Yes.
what I did was, first of all, we can simply we can simply use maths. So what I thought was 1, 2, 3, 4, 5, 6, or let's suppose n is equals to 4 and k is equals to 6. So the first order of lexicographical order would be 1, 2, 3, 4.
Right.
Then what we can do is we can simply classify each and every index whether it is odd or even, and the first index was odd, second index was even, and similar patterns continues. So what we can do is we can first of all check how can we basically turn around or make permutations. Condition number one is we can swap odd places, and condition 2 is we can swap even places. Condition 3 is we can swap odd and even both simultaneously. And that's all, I guess. These are the three cases. And there would be two special cases. If let's suppose n is even or n is odd. If n is even,
I got your
uh,
point. I got your point. If n is even, you can start with an even number as well. But if n is odd, you need to start with an odd number, right?
let me complete it. I actually wrote a mathematical formula for number of permutations for even number. So number of permutation for even number would be, if number is even, let's suppose n is 4, then permutations would be permutations by swapping each even number with each even number, plus permutation by swapping each odd number with each odd number, plus permutation by swapping odd number while even numbers are being swapped, plus permutation by swapping each even number when odd numbers are being swapped. And for odd number, I thought because we have a case where there is in odd numbers. For example, there are five odd in any case. Let's suppose we are taking 9. So in 9, odd would be 1, 3, 5, 7, and 9, which is equivalent to 5, and odd are, sorry, even are 1, 2, 2, 4, 6, and 8, which is equal to 4. So what happens is कि हाँ मतलब ऑल पॉसिबल तरीके ही यूज कर रहे हैं हम। हाँ तो होगा क्या कि हम ऐसे ऐसे काउंट कर लेंगे, बट सर प्रॉब्लम इज कि इसका टीएलई आ जाएगा इसमें।
TLE, right. So yeah, so should I tell them?
यस यस श्योर।
Okay. So as he told, this was only coming to my mind when I first started solving this problem. That like first of all, let me first of all explain the problem, because I haven't explained the problem till now. So let's suppose you are given n is equals to 4 and k is equals to 6. So what you need to do is, you need every time when you are constructing any permutation, so that permutation should be like you should not have any two consecutive odd numbers, and you should not have any two consecutive even numbers. So you should have something like this: odd, even, odd, even, odd, even, or even, odd, even, odd, even, odd, something like this. Okay. So let's suppose for n equals to 4, I start with an odd number. So I have 1 over here. So the next odd number will come at the third position, right? And at the second position and the fourth position, we will have an even number. Do you guys agree? Right? Similarly, over here, I can start with an even number as well. So if I do that, then in the third position, I will have an even number. And in the second and fourth position, I will have an odd number. Do you guys agree? Yes. Okay. But let's suppose if the value of n was 5, then can you start with an even number, guys? Can you start with an even number? No, right? You can't start with an even number. So if the value of n is odd, you need to start with an odd number. If the value of n is even, you start with an even, odd, and odd number. Okay, cool. So now the question says that you need to construct all the possible permutations, and you need to return the kth lexicographically smallest permutation. So for example, for this particular example, 1, 2, 3, 4, this will be the permutation for k is equals to 1. Then I thought that, okay, let's swap, let's keep 1 over here. I don't want to disturb this one. Let's swap this 4 and 2. So I will get this thing for k is equal to 2. And then for the third one, I thought, okay, let's start with 2. Then you have 1, 3, 4. This was for k is equals to 3. Similarly, you have 2, 3, 4, 1 for k is equals to 4. Then you have this 3, 1, 2, 4 for k is equals to 5. Then you have 3, 4, 1, 2 for k is equals to 6. Then you have 4, 2, 1, 3 for k is equals to 7. And then you have 4, 3, 2, 1 for k is equals to 8. I don't think you have any other permutations. Yes. So if you just observe, you have n is equal to even, right? This means you have n by 2 odd numbers and n by 2 even numbers. So the total number of permutations is this: n by 2 odd numbers can be arranged within themselves. So n by 2 factorial multiplied by this n by 2 even numbers can be arranged within themselves, n by 2 factorial again, multiplied by, since you have two options, you can either start with an odd number or an even number, so multiplied by 2. So basically for n is equals to 4, you will just observe that you have 8 possible permutations. Okay, so you guys can observe you have 8 possible permutations, and what you need to do is you need to return the 6th lexicographically smallest permutation. So for this particular problem, what you will do, you will simply return this. So this is what the problem is. How multiplied by 2? See, since you can start either with an even number or an odd number for n is equal to even. So for n equals to even only, the total number of permutations will get multiplied by 2. So if n is even, then you can either start with an even number or an odd number, right? So for that reason, I am multiplying it with 2. Total permutations by 2. Yes. So do you guys get the problem? And if let's suppose the total number of permutations is 11, and I ask you the 13th smallest permutation, in that case, you simply return a empty list. This is what the problem says. Anyone having doubt in the problem, guys? Clear? No doubt? Okay, cool. So if you guys just observe the constraint of this problem, n was given of the order of 100. Okay. So you definitely can't go over all the permutations. So if you're thinking that, then don't try. It will be of 100 factorial, 100 into 100 factorial time complexity, and it will not work, definitely. So if I give you an n, if I give you n, and it is given that the value of k is lesser than equals to 10 power 50. Okay. So whatever I discussed before, this was the first thing that was coming to my mind, that okay, if I have this 1, 2, 3, 4, then first of all, I will try to keep 1 over here. So I will swap this 2 and 4. Then I will move this 1, bring this 2 over here. So I have to bring 4 over here, 1 over here, 3 over here. And these were the things I was thinking. But I was not landing at any fruitful or something that would help me to write the code. I was not able to code this thing. So what I thought was that, okay, let's see the case when we will simply return an empty list. Okay, I thought of something like this. So we have n of the order of 100, right? And k is of the order of 10 power 50. So if I have n with me, I can count the number of permutations, right? Yes, I can't calculate it because that factorial value will be very large. But mathematically, I can write that if the value of n is even, then the total number of permutations will be n by 2 factorial multiplied by n by 2 factorial multiplied by 2. And if the number of numbers is odd, then the total number of permutations will be basically CL value of n by 2 factorial multiplied by basically the number of odd numbers factorial multiplied by number of even numbers factorial. This is something that we can definitely write if we know the value of n. Do you guys agree? These are the total permutations that I have. Now just say me one thing. If I tell you that the value of n is, let's suppose, 100, then can you see the total number of permutations you have? 50 factorial multiplied by 50 factorial multiplied by 2, right? This is a huge number. This is a huge number, guys. So what I did was, I know that for greater values of n, the first few numbers will look something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Some few numbers will look something like this. I only need to rearrange last few numbers to get the kth smallest permutation. Do you guys agree? I only need to arrange last few numbers to get the smallest to get. Okay, what I am telling is, if let's suppose the value of n is 100, then I know this will be the total number of permutations, which is actually a very large number, and I am looking for the kth smallest permutation. So since I am looking for kth smallest permutation, so the first few numbers will look exactly the same as they would look when in their first permutation. First few numbers will look exactly the same, and I only need to arrange last few numbers to get the kth smallest number. This is something that I thought of. Is it right or wrong? Tell me. Right? Cool. So how many numbers I need to rearrange by my own? I started computing that thing. So for that, I would simply like to go to Google once. So what I did was, let's compute a value of 10 factorial. Like, see, if I am having at the end, if I am, let's suppose, having 20 numbers. If at the end I am, let's suppose, having 20 numbers, then can you tell me how many permutations will I have for 20 numbers? It will be 10 factorial multiplied by 10 factorial multiplied by 2, right? Do you guys agree? Do you guys agree? Now I tried to compute this result, that what this result comes out to be. And for that, what I did, I computed this 10 factorial multiplied by 10 factorial. So see, I am getting a value somewhere close to 10 power 13, right? I'm getting a value somewhere close to 10 power 13. And I am told in the problem that the value of k can go up till 10 power 15. So what I did was, for the safer side, I told that, okay, let's take the last 24 numbers and I will rearrange them. Let me just see in the code. I took the last 24 or 22. Yeah, I took the last 24 numbers. I took the last 24 numbers and I told that, okay, I'm going to rearrange these numbers only. And if I have the value of n greater than 24, then basically the first some few numbers are going to look something like this: 1, 2, 3, 4, 5, 6. And then I will try to rearrange these 24 numbers. And the reason was that if I just compute this 12 factorial, like for the 24 numbers, how many permutations will I have? 12 factorial multiplied by 12 factorial multiplied by 2, right? So when I computed this 12 factorial, just compute this 12 factorial, you get the value somewhere around 10 power 9. So 10 power 9 multiplied by 10 power 9 is actually 10 power 18. That exceeds the value 10 power 15. So I decided that, okay, if the value of n is greater than 24, then the first few numbers will look like this, and then I will rearrange the 24 numbers. And if the value of n is lesser than equals to 24, then I can simply play with the starting numbers only, that is starting from 20. So this is what I thought of. Is it clear till now, guys? Is it clear, guys? Yeah, 22 would work as well, I think. Yes, I thought of 22 only. I don't know why I coded for 12 factorial. I just went for the safer side. 11 factorial is 3, it's approximately 10 power 8, 7. It will work as well. It will work. You can go with 22 numbers as well. So just for being at the safer side, I went with 12. So basically 24 numbers. Is it okay? Yes? Okay. So now I will just solve the problem if I have 24 numbers. For 24 numbers, I will solve the problem, and for all the remaining numbers, I know what to do, right? Now let's see how we will solve this. And let me try to make you all understand this problem via this particular example. 1, 2, 3, 4. That is the value of n is equal to 4. And I am looking for the sixth permutation. Okay. So let's see how we can solve for this. So just tell me one thing. Over here, you know that you can start either with an even number or an odd number, right? So I think this thing is clear to you guys when we can start with an even number or when we can't start with an even number. This is something that you guys know, right? That is clear. Okay. So over here, just tell me, can we start with an even number or can we start or we can't start with an even number? We can every time start with an odd number, but over here, just tell me, can we start with an even number or not? Yes, we can. Okay, great. So let's see how beautifully I will solve this problem. This is very easy. Once you figure out this logic that I am going to tell, after that the question will seem very, very easy. So currently the value of k is equal to 6. The number of even numbers that I have is 2. I am denoting it with C1. And the number of odd numbers that you have is also 2. I am denoting it with 2. And I am just maintaining a map that tells me whichever number I have already used. Okay. Whichever numbers I have already used. So initially my map is empty. I have not used any number till now. So is the initial configuration clear, guys? I am standing over here. I am at the beginning. I am looking for the sixth permutation. The number of even numbers that I have is 2. Number of odd numbers that I have is again 2. And initially in my map, I don't have anything. Right? Agree? This map tells me that whichever numbers I have already used for creating the permutation. So initially, since I have not used even a single number, so this map is empty. Do you guys agree with this, guys? Yes, no? Yes, okay. So now we can either start with an even number or an odd number in this particular case. So what you will prefer? Tell me what you will prefer. What you guys will prefer? to start with what number? What you guys will prefer, your permutation, if you're looking for smallest permutation, you will start to prefer, you will try to first keep 1 over here, right? You will try to keep 1 over here, first of all. Yes, 1, right? So keeping 1 over here, can you guys tell me the number of permutations you will have? Now, this is something that you can calculate, right? Do all of you agree that keeping 1 over here, I will have 2 permutations? And how did you get that, Anand? It is nothing but C1 factorial multiplied by C2 minus 1 factorial. Do you agree? Do all of you agree? So keeping 1 over here, I got 2 permutations and the value 2 was actually lesser than this 6. So what I will tell is that, okay, keeping 1 over here does not benefit me. So let me just subtract from this 6. Let me subtract 2 because 2 was the number of permutations I was getting when I was keeping 1. So do you guys agree the value of k will become 4? And now I am pretty much sure that I can't keep 1 at the start. Do you guys agree? Yes, no? I can't keep 1 at the start, and after keeping 1, I had 2 permutations, so I simply subtracted 2. I will come to that, Nikunj. Why you are hurrying so much? Till now, just tell me. Keeping 1 at the front, I know the total number of permutations is 2. And since I want to know the 6th permutation, so definitely this 2 is lesser than 6. So I simply subtracted 2 from the 6. I got the value of k is equals to 4. Do you guys agree? Just focus on this, Himanshu, for now. Do you guys agree that I can't keep 1 and I am looking for the 4th permutation, right? If I can't keep 1, can you guys tell me the next number that I can look for? The next number that I can look for, 2, right? Because I can start with an even number as well, right? So the next number is 2. Keeping 2 over here, can you guys tell me the number of permutations? Same 2, right? And again, this 2 is lesser than 4. So what I will do is I will just subtract 2 from this and I will tell, okay, I can't start with 2 as well. Agree? Yes. Next, which number I will look for? 3, right? Keeping 3 over here, tell me the number of permutations that you have. 2 permutations, and this value 2 is actually exactly equal to the kth value that I was looking for. This means that definitely if the total number of permutations is 2 and this value is greater than equal to the permutation that I am looking for, let's suppose this value came out would have come out to be 4. Now again, since this value is greater than 2, then definitely at this particular position, I will have the number 3. Right? Then definitely I will have at this particular position, keeping this number, the total number of permutations comes out to be 2. That is actually greater than equal to the number of permutations I am looking for. Greater than equal to the permutation number that I am looking for. Hence, I can say that I can place 3 over here. Do all of you agree, guys? Yes. So what I will do is in my answer vector, I will simply push 3. In my map, I will push 3. That will tell me that, okay, I have used this 3 and I will just decrement the count of odd numbers. Is everything clear till now, guys? And now currently my value of k is 2. Okay. Right? Cool. Now I will move on to get the next element. Now the next element should be an even or odd. I can simply check that by checking the last value that I have filled in the answer. Since the last value that I have filled in my answer is an odd number, so definitely over here I would have an even number. Agree? Yes? Okay. So the value k is equal to 2 and I have already 3 over here as the first element. For the second element, what will be your first choice, guys? what will be your first choice? 2, right? Keeping 2 over here, can you guys tell me the number of permutations I will have? Can you guys tell me the number of permutations I will have keeping 2 over here? 1, right? Because the number of odd numbers is also 1, number of even numbers is also 1. So do you guys agree I would have only 1 permutation and that value is actually lesser than 2? So this means keeping 2 over here will not help me to reach the required permutation. So what I would do is I would simply subtract 1 from this. So the value of k will become 1. And now I will try to fill some other element in this second position. So what is the other element I can fill, guys? 4. Do all of you agree? If I fill 4 over here, can you tell me the number of permutations I will have? 1, right? And that value is actually exactly equal to k. So this will become clear that, okay, I need to fill 4 over here. So what I will do, I will just fill 4 in my answer and I will just fill and I will tell that, okay, I have used this 4 as well. Then I will go on to fill the third element. Now again, the third element should be an even or odd. That is determined by the last element in my answer vector. Now since in my answer vector, the last element is an even number, so this will be an odd number. So I will just start. First of all, I will see 1. So in my map, I will see that whether I have used 1 or not. So definitely my map will tell me that, yes, you have not used 1, so you can use it. So I will see that if I place 1 over here, how many permutations do I have if I place 1 over here? Not 0, 1. You have 1 permutation, right? You can place 2 over here and you will have a permutation if you place 1 over here. And that value is again exactly equals to k. So definitely you can keep this 1 over here and proceed. So again, k is equals to 1 and you will try to fill the fourth element. You have only one possible option. Fill it with 2 and you will get your kth permutation. So this is actually the entire logic or the idea via which we can solve this problem. So tell me, do you guys understand it or not? Should I show you all the code now? The flow of k. Okay. See, if you have some k, you try to fill a number, you try to see how many permutations you have after filling this particular position with this number. If that value actually exceeds the or it is actually equal to k or it exceeds the k. Let's suppose the value of k was 2 and the number of permutations came out to be 4. This means keeping 2 at this particular position, you have 4 possible options. And out of this 4, you only need to return the second one. So you can return the second one, right? So this place will be occupied by 2. We will be pretty much sure. But if let's suppose keeping 2 at this particular position, the number of permutations would have come out to be 1. This means that keeping 2 at this position won't help because I am looking for the second permutation and I have only one possible permutation keeping 2 at this particular position. So I will just say that I will just make my k as 2 minus 1, that is 1. I will say that, okay, keeping 2 over here, I have already done one permutation. And then for, okay, what I am telling is, if let's suppose you fill 2 over here, and after that you have 4 possible permutations. So tell me, should you place 2 at this digit or you should place any higher number over here, any higher digit at this particular position? You can place 2, right? Because keeping 2 over here, you have 4 possible permutations and you need to return only the second smallest. So you can return, right? But let's suppose you kept 2 over here and you had only one possible permutation. So definitely over here, you can't keep 2. Yeah, keeping 2, you got one permutation. So your k will become 2 minus 1, that is 1. Now you only need to look for the first smallest permutation. So removing this 2, you will just try to increment this value and check for more permutation. That is what we did. We incremented this 2 to 4 And then we saw that, okay, the total number of permutations keeping this 4 was 1, which is exactly equal to what we are looking for. So we will just keep 4 over here and move forward. This is what we are doing. Can you unmute yourself and let me know what doubt you have? If you have some doubt. Yes, if you want, you can. If you have the doubt, you guys can unmute and let me know. Otherwise, I will show you the code.
Clear, like, okay, once I would go through it after the class, then it would be clear.
I am not able to hear you. You are very low. Should I? Is it clear? Okay, let's go to code. Okay. So what I did was I pre-computed the factorial values before only because setting a number, I need to know the number of permutations, right? So I computed the factorial till 12. So this is how I am just doing calculating the factorial till 12. So I have pre-computed 2 factorial, 3 factorial up till 12 factorial. Initially, this is my vector int answer. My C1 denotes the number of even numbers. C2 denotes the number of odd numbers. So number of even numbers will be floor value of n by 2 and number of odd numbers will be basically ceil value of n by 2. Okay. Then I constructed a map that tells me which all numbers I have already used. Now over here I have coded for 22 only. So I was talking of 24, but I have coded for 22 only. So if n is greater than 22, then for every number from 1 till lesser than n minus 22, I'm just telling they will remain in their position. So answer.pushback I, used of I is true. I have used this number. If the number is odd, I am decrementing the count of odd numbers. Otherwise, I am decrementing the count of even numbers. So if the value of n is greater than 22, I am just filling the first few numbers from before. Is this thing clear, guys? Yes? Okay. Otherwise, I have just kept this variable f as false. I will just tell where I am using it. Let's move forward. If answer.size is lesser than n and k is greater than 0, till then I am running this loop. Okay. So why answer.size lesser than n? Because I need to construct the entire answer which will be of size n, right? And the value of k should definitely be greater than 0. For that time, I am running this code. Now, there are 3 cases I am handling. The first case is if my answer is empty and my value of n is even. What does this mean, guys? Answer is empty means I have the value of n lesser than equals to 22, right? Do you guys agree? Because I don't
Yes.
have anywhere. Yes. So if answer is empty and my value of n is even, then definitely, as I am going to fill the first number now. So if I'm going to fill the first number, so the first number can either be an odd number or an even number. Agree? Because the value of n is even. So I'm just iterating each and every number from I is equal to 1. Just a minute, guys. Just a minute. Yes. So I'm just iterating over each and every number from I is equals to 1, I lesser than equals to, and I plus plus. If I have not used that number, so basically in my map, I don't have that number. So the number of, if I'm using this number right now, so the number of even numbers that I will be left out with is the number of even numbers I have minus, I will do a -1 if this I is an even number. So I'm doing a -1 if this I is an even number. Similarly, the number of odd numbers that I will be left out with after using this number is the number of odd numbers I have minus if this particular number is an odd number. So just tell me one thing, if I just place this number at this particular position, then how many permutations we have? It is basically the number of odd numbers factorial. multiplied by number of even numbers factorial, right? Do you guys agree? Yes, no, anything? Do you guys agree? Yes. So I have already computed this factorial thing, right? So I'm just multiplying these two. Now, two cases. Either if the value of k is 1 or the position or basically the total number of permutations I got that is greater than equals to k. What does this mean? It means that I will place this particular number I at this particular position. Do you guys agree? I have discussed this thing. Similarly, for k is equals to 1, every time we were doing that only, right? You can just remove this thing. You don't need this. Even if you remove this thing, it will not be a problem. I will show you the code after removing this as well, but this is how I have coded it. That if the value of k is 1, so definitely position will be greater than equals to k only in that case, right? So if this is the case, then do you guys agree? I will place the current number I at this particular position. Do you guys agree? Yes, no, anything? So just ignore this thing for now. So what I am doing is in my answer, I am pushing back this I. So I'm using this I. So used of I is true. I have used this number. And now the total number of odd numbers will be, total number of even numbers will be equals to x1. Total number of odd numbers will be equals to x2. Marking this t as true and breaking. So I maintained a variable t as false. Initially, I am marking this as true and I am breaking from it. Breaking from this for loop. I have got the number that I need to place at this particular position. But if this is not the case, then from my k, I am simply subtracting the number of permutation and I will go to the next number to look for whether I can fill this particular position with this particular number or not. Okay. If after coming out of this for loop, my t is still false, I have initialized it with false and it is still false. Can you guys tell me what does it determines? Can you guys tell me what does it determines? The value of t is still false. This determines that the number of permutations, the value k given, is actually greater than the total number of permutations that actually exist. So in that case, what I'm doing is I'm simply returning an empty list. Is this part clear? Yes. Is this part clear, guys? Now let's move on to the next case. The next case is if the answer is not empty, if either the answer is not empty and the last number in the answer that we have filled with is an even number, or the answer is empty and we have the value of n as odd number. In both of these cases, do you guys agree? The current position will be filled by an odd number. In both of these cases, just tell me. Either the answer is not empty and the last number we have filled is an even number, or the answer is empty, but the value of n that we had is an odd number. So in both of these cases, do you guys agree that the current position will be filled by an odd number? Yes. So what I am doing, I am just starting to iterate over all the odd numbers from 1 till lesser than equals to n. So I'm just incrementing every time my I by 2. And if I have not used that number before, so this will be the number of, if I use it over here, number of odd numbers will be, number of even numbers will remain as C1. Number of odd numbers will get subtracted by 1. Total number of permutations I have will be this. And again, the same code, entirely the same code as we have discussed. And similarly for the else part, when we know that we are going to fill the current position by an even number. So I just started iterating over every even number from 2 to less than or equals to n. And again, the same thing. That if I have not used that number, so let me just comment this thing. So if I have not used that number, so if I use it, then how many I have? And again, entirely the same thing. So after coming out of this while loop, what I am doing is, if my value of k is greater than 0 and not f. So over here, I have used this f. So this f, if anytime my k becomes 1, this tells me that I have a permutation. I have a valid permutation. So if my k is greater than 0, so every time if my k was 1, I was marking this f as true. So if at the end my k is greater than 0 and f is not true, I am returning an empty list. Otherwise, I already have the answer in my answer vector, so I am returning that answer. So this is how actually you can solve this and code this problem. Yes, implementation skills are needed, and first of all, you need to figure out this thing. So some mathematical skills are also needed. So this is how actually you can solve this problem. Just tell me if you guys understood this or not. Yeah, for that reason, I was telling that I don't know how like approximately 500 or 600 people got all killed. So for that reason, I was telling that I don't think so many people can actually solve this by their own. So that's all from today's PhD. Thanks for joining, guys. Let me just stop the recording.